I ain't got no home, I'm just a roaming around, just a wandering worker. I go from town to town, and the police make it hard wherever I do go. And I ain't got no home in this world anymore. I plucked in your mines and I gathered in your corn. I've been working, mister, since the day I was born. Now I worry all the time like I never did before. And I ain't got no home in this world anymore. Well, my brothers and my sisters are stranded on this road, a hot and dusty road that 1,000,000 feet have trod. Well, a rich man took my home and robbed me from my door. And I ain't got no home in this world anymore. Was farming on the sheds, and always I was poor. My crops I lay into the banker's door. Well, my wife took down and died upon the cabin floor. And I ain't got no home in this world anymore. Now, listen very carefully. Beach Haven ain't my home. I just can't pay the rent. My money's down the drain and my soul's badly spent. Beach Haven looks like heaven when old black folks come to roam. No, no, old man Trump, old Beach Haven ain't my home. Well, as I look around, it's mighty plain to see. The world is such a great and a funny place to be. Oh, the gambling man is rich and the working man is poor. And I ain't got no home in this world anymore. Oh, the gambling man is rich and the working man is poor. And I ain't got no home in this world anymore. Thank you. Yep, believe it or not, Donald Trump's old man was Woody Guthrie's landlord.
Well, hello, ladies and gentlemen. My name's Julie McCrossan, and it's my great pleasure to welcome you this evening to the Australian National Conference 2021 on Huntington's. And I'd like to particularly welcome people who are living with Huntington's disease or family members. It's really fantastic that you've joined us. Let me, before I start, acknowledge that we're broadcasting to you this evening on Aboriginal land. I'm on the land of the Gadigal people, and so is Lewis Kaplan, the Chief Executive Officer of Huntington's New South Wales ACT. He's also on Gadigal land, and as well as being a key organiser this evening, he's behind the scenes helping us with all manners of cyberspace. And I also want to thank Bruce Hearn, who was singing that musical tribute to Woody Guthrie. Many of you may know this. I didn't know that Woody Guthrie, who's a very famous American folk singer who was a huge influence on Bob Dylan and many other leading folk singers of a political nature in the United States. Well, Woody Guthrie lived with Huntington's disease, and his second wife played a key role in the foundation of the Huntington's Disease Society of America. So, welcome to our second webinar in this conference. The theme tonight is a research update. We've got magnificent speakers for you. I do want to acknowledge that we are recording this and it will be available on the website, Huntington's New South Wales ACT website next week. And so you will be able to review it. And many people have registered with the intention of viewing it in the YouTube format, and including quite a number of people from Huntington's, Queensland, who have their board meeting this evening. And so a number of people have sent their apologies, but say they really look forward to reviewing this on YouTube. And I would like to again say welcome, because I know some more people are joining us as I speak, but to give you just a couple of housekeeping things. First of all, thank yous. Thank you to Roche for their sponsorship for these 4 webinars to make up this Huntington's Australian National Conference 2021. Thank you to our supporter, the Australian Government's National Disability Conference Initiative, and to our exhibitor, Novacor, a company, an Australian-owned company that make specialist beds and chairs for people with Huntington's. And we saw some of their amazing products in our first webinar for this conference. Now, as our speakers speak, I want you to look at the Q&A. If you wiggle your pad or your mouse, you'll see there's a Q&A option there. If you click on that, you can put questions or brief comments all the way through. Remember, in this webinar format, we can't see you or hear you. So the way to bring questions to our speakers, and after our 3 presentations, there will be a 20 to 30 minute Q&A session. And as well, there'll be a special guest with us. And I will have a myriad of questions, I always do, but it's your questions that matter. So please put them in the Q&A throughout the evening, and I'll be taking notes as we go. So I think we're ready to begin. And actually, first of all, I just want to hear a little bit about you and let you know a little bit about each other. So we're going to do a poll. And the first question I'm going to ask Lewis to put it up is about where you are from. Could you click one of those options? And I can't see the international option. Lewis, I don't know that we can see the international option on the screen. But I've discovered we can wiggle it up and down. Can you see that? So if you're joining us internationally, could you please slide up and click international? Well, could I see the results now, please, Lewis, in cyberspace? And I'll just let you know. So 4% from the ACT, 38% from New South Wales, no one from the Territory, 11% from Queensland, 2 from South Australia, 13% from Tasmania, 11 from Victoria, 11% from Western Australia, and 11% internationally. And for those international people, we'd love it if you could put into the Q&A or to the chat which country you're from. And so if you could close that now, thank you. And our second poll question is, who are you? And Lewis is going to put up a poll, and you can tell us what group you're in. It's not there yet, but here it is. So a Huntington's disease family member, and then you'll see the other options there before you. If you could click the one that best describes you. And again, I'll get the people who fit under other to pop into chat or the Q&A what country you're from. Well, thank you, Lewis. I think we'll see the answers for who we are. So 30% are from family members of people with Huntington's disease, 15% doctor, academic researcher, no service providers this evening, very different for our daytime session. Allied health, 19%, care workers, 13%, a member of a Huntington's disease association or volunteer, 6%, 6% nurses, 4% students, and 6% other. And if we could take that away now, Lewis, I'll just share with you that we have people from Switzerland, a number of people from New Zealand. We welcome people from the pharmaceutical industry as well, and others may wish to put it in where they're from as we go along. Well, let's get moving. I'm so excited to hear our speakers, and our first speaker this evening is Professor Clement, a clinical epidemiologist and a cognitive neurologist. He's the director of the Huntington's Diseases Service at Westmead in Western Sydney, where they see around 75% of people living with Huntington's disease in New South Wales. And Clement is a researcher. He runs clinical trials, including, of course, for people with Huntington's disease. He's also very sick, so he's going to choke and cough. We don't mind that, so long as you get the appropriate test out there at Westmead tomorrow. And so this is deaf sign clapping to welcome Clement. Welcome, Clement.
Hello, can you hear me?
Yes, we can. All
Fantastic. Good. Thanks very much for the introduction, Julie. Yeah, as I begin, I also want to acknowledge the traditional owners of the land on which I stand today, Gadigal people, and to pay respect to the elders past, present, emerging. Also, I want to send our special thoughts to our Victorian colleagues and friends as they face another COVID shutdown, and I very much hope that that will be a short one. Okay. As Julie said, the bad news is that I've got a bit of a cold, so I might cough throughout the talk today. But the good news is not COVID, and that because we are talking through Zoom, I'm not going to infect you. So in the next 15 minutes or so, I would like to tell you about 7 recently completed or emerging trials. 2 of them are the ones you've heard a lot about, Roche and Wave. The 3 other gene therapy trials like Unicure, Novartis, and PTC, and 2 non-gene-based trials. I will only go through the Roche trial in detail. The rest I'll just summarize. But having said so, I'll put in extra material in the slides if you would like to follow up on the details. There's no need to take notes because right at the end of the talk, I'll put up a summary slide, which also put in the take-home message for each of the trials. Okay. So Roche and Wave. Just a brief introduction to gene silencing therapy. This is a cartoon, if you like, of how it may work. As you know, our bodies are made out of cells, in which within each cell, there's genetic material called DNA. And we all have 20,000 genes each. And it is mistaken one of those 20,000 genes that could cause Huntington disease. We also have 2 copies of each gene, one from mom, one from dad. Most people with Huntington disease has got 1 abnormal copy of the gene and 1 normal copy. As the DNA gets transcribed or expressed, it became RNA, which is the intermediate step before it gets translated into abnormal proteins. And as you know, the abnormal protein then could act on parts of the cell to cause problems, such as the mitochondria. It can also directly affect what happens in the brain, reducing growth factors, as well as changing the balance of neurotransmitters, such as dopamine. Currently, we've got some symptomatic treatments, such as tetrabenazine and antipsychotics, which could partly improve the dopamine imbalance. However, as you would have imagined, only if we can go all the way back up to the beginning of this disease process, then we will have a more powerful way of treating Huntington disease. Since we are all born with our DNA that can't be changed, the next best thing is to go to this step, the RNA step, or the expression of the abnormal gene. And that's the idea of these gene silencing therapies. It goes to that step and stop the abnormal copy of Huntington gene expressing itself. So with that in background, that's why there was so much excitement a few years ago when Roche had this antisense oligonucleotide, or ASO, which in early phase 1 trial showed a dose-dependent way of reducing the amount of abnormal Huntington protein. So just go through the graph a little. The vertical axis is the percentage change from baseline before you have 3 or 4 months of the drugs. And the horizontal axis is the amount of drugs. So people that only have placebo, as you can see, on average, the amount of Huntington or abnormal protein didn't change. However, as you increase the dose, as you can see, the horizontal line, which is the average for the group, keep lowering. And in fact, at 120 milligrams, almost everyone had at least a 40% reduction in the abnormal or in the amount of abnormal mutant Huntington protein. And on that basis, the large generation HD1 trial was designed. It was a large phase 3 trial, 780 people joining it worldwide, people with early Huntington disease. The trial go for 2 years, so it's got a long period of time to see how people respond to the drug. And people are randomized 1 to 3, randomly assigned to either placebo, that is like a non-active infusion, or every 8 weeks or every 16 weeks having Tominersen, the ASO, through a lumbar puncture. And to determine whether the drug works or not, you've got the primary outcome, which is a change in this score, which takes into account a person's movement, cognition, and day-to-day function. Now, by February this year, about 60% of people in the trial has completed about 3/4 of the trial. So that means there is actually sufficient data to make some conclusion. And that's when the data committee saw this. Unfortunately, the high dose group was associated with worse outcome and closed the trial. Let me go through this chart in more detail. This is the most complicated chart for this talk, but I think it's probably quite helpful to understand and see why the trial was stopped. I think there was a lot of disappointment, and this might explain why that was decided. So again, the horizontal axis is time, 5 weeks, 21 weeks, 37 weeks, 53, and 69 weeks. The vertical axis is the change in this composite UHDRS score. In summary, the higher up you're on this chart, the better you are, the lower, the worse you are. Now, there are also 3 sets of symbols in different colors. The gray symbols represent the placebo group, and the orange symbol represent the low dose, and blue the high dose group. Excuse me. Let's start with the placebo group. Concentrate on the gray symbols. The dot is the average for that group. The lines around it are called the confidence intervals, so the measure of uncertainty. So the practical way of looking at these measures is if 2 measurements have overlapping confidence intervals, that means statistically we can't tell them apart. But if 2 groups have these lines that are not overlapping, that means they're statistically different. Looking at the gray groups again, over time, as you may expect for people having placebo or no active drug, the composite functional and motor and cognitive score worsen over time. It goes lower. Similarly, for the low dose group, the orange group, it also goes lower. You might get a feeling that the orange group might be going lower slightly faster, but those lines are overlapping with placebo, so they're not statistically significant. Now we look at the blue group. The blue group, the high dose group, at the beginning, since they're all randomized, all 3 groups are similar. But after having the drugs, the blue group over time, as you can see, deteriorate more rapidly. In fact, in the last 69-week point, the confidence interval no longer overlaps with placebo. That means that statistically, we have got good evidence to suggest that that high dose group actually did worse than the placebo group. And that was the reason why the trial had to be stopped early. It certainly is not a result that anyone expected, and certainly not a result that anyone wants to see. And certainly it's very disappointing given the hours and hours that people with HD and their family had devoted to this study, coming to the hospital, sitting in the room waiting, having the lumbar puncture. So what next? Roche has said that it would process all the biological samples as quickly as possible and also reanalyze and learn as much as we can from this trial. In fact, this trial is certainly the most complete and data set we've had about Huntington disease, and without doubt with the greatest depth of biological samples. Roche is going to look at whether different doses or different frequency of medication could be associated with a difference. They're going to look at whether certain population, i.e. earlier or later, people with earlier or later disease might do better. They're going to re-examine the idea of, lowering Huntington disease, Huntington protein and improving someone clinically, particularly as the Roche drug lowers both the expanded or abnormal Huntington protein as well as the normal one. They're going to also look at whether the ASO as a vehicle has got particular issues associated with it. Now, switching to the other trial, the WAVE trial. WAVE has got a slightly different compound. This one, rather than lowering both abnormal and normal copies of the Huntington gene from expressing themselves, this one only silence or reduce expression of the abnormal copy of Huntington gene. What it does is if you like, develop a little hook and use that hook to hook itself onto only the abnormal copy of the Huntington transcript, but not the normal one, and reduce it. That was the theory, and there were some initial results that were quite encouraging. Unfortunately, this trial also had to close. I won't go through the detail, but in short, they found that the drug didn't lower the level of abnormal Huntington protein at all. At the higher dose, about half of the people also had quite serious side effects. Nonetheless, they've developed a third drug, SNP3, and it's got a different chemistry, and that's due to go into trial next. And the reason why this trial was stopped is because it doesn't seem to be affecting the amount of abnormal protein. Okay, so that was Roche and WAVE. What you may or may not know is there are actually quite a few other drugs aiming at the gene therapy approach. And these include the Unicure one that you might have heard about, and also two oral agents you may or may not have heard about. I'll go through them briefly for you. So AMT-130 from Unicure is a slightly different mechanism. It uses what you call microRNA, which is small stretch of RNA. It packages this in an inactivated virus, and then it's then injected into people's brain, and it's a one-off procedure. As you imagine, this is a difficult and complex trial to run, and it's taken them some time to redesign its protocol. Nonetheless, so far they've been able to do 10 injections, and that's been well tolerated, and they plan to go up to 40 people in the trials in the coming months. So that's Unicure. There's also another oral gene silencing agent called Branaplam that has Novartis as the sponsor. This one is quite an interesting one in that it was an oral small molecule that you can take once a week, but it was actually designed for another disease, spinal muscular atrophy. However, it just so happens that the mechanism there, the splicing of the gene associated with spinal muscular atrophy, shares a certain genetic signature as the Huntington pseudoexon. It's a lot of technical terms, but basically it means that Branaplam actually would also reduce the amount of Huntington expression. This is quite a complex graph, but the blue and red lines is what you can see. And because they've already used this drug amongst people with spinal muscular atrophy, they could look at their blood and they realize that it reduces the amount of Huntington expression by about 25 to 50%. As a result of that, they've already had a phase 1 trial for healthy adults, and there'll be a phase 2 trial starting probably July, August this year. PTC also has similar splicing small molecule. And this is a more complex picture, but it's really the same thing. The drug managed to bring in an abnormal cassette or exon for the gene, and then that leads to the transcript being decayed. That means you then end up not expressing that abnormal protein. They are also halfway through the phase 1 trial, and it seems to reduce the amount of transcript or expression of the abnormal Huntington protein as well, and also the normal Huntington RNA level, both abnormal and normal Huntington RNA levels. So in addition to the 2 trials that we know, Roche and Wave, and the 3 trials with other genetic mechanisms, there are 2 additional trials using non-genetic mechanisms. One's from Vaccinex, Pepinemab, which is a monoclonal antibody against a signaling molecule. What it does is it reduces the amount of inflammation around the brain. That's been tested in about 250 people already. The trial has been designed to test specific things, but it didn't quite reach what the trial was designed to test. But there are some encouraging data showing that it might have some positive impact on cognition. And therefore, they have planned another phase 2/3 trial, and that should be coming up soon. Finally, Prilenia also has another compound, Pridopidine, and some of you may remember it from a few years ago. Pridopidine is a drug that's been tested in 2 or 3 large trials already. And it was designed to dampen the abnormal movements in Huntington disease. However, people realize it also has got additional properties that would stop neurons from dying in Huntington disease. When they reanalyze the data, there's also a suggestion that it might stop people deteriorating in terms of their overall function. So there'll be another new trial for this drug as well. Okay, so in summary, these are the 7 trials we've talked about. For Roche, as we explained in a little bit more detail, the trial was halted. The high dose group did worse than the placebo group. For Wave, the trial was also stopped because it didn't reduce the amount of mutant Huntington protein. However, it does have another compound that's coming onto trial. Unicure, the one that we inject viral carriage of microRNA into the brain, that's still in early stages. It's been 10 infusions and it's well tolerated. Then we have 2 oral gene silencing drugs, one with known safety, one's got phase 1 safeties being established. On top of these 5 gene therapy-based trials, we also have 2 non-gene therapy trials. The antibody that lowers inflammation. There's some encouraging cognitive data or memory testing data there, and a new trial will be coming online. And also with Pridopidine, again, potentially could improve function. In addition to these 7 trials, I just want to tell you a little bit about another trial that we've been planning locally, funded by the NHMRC, where we'll be testing N-acetylcysteine among people who are pre-manifest Huntington disease expansion carriers. Okay, so in conclusion, 1, the first 2 gene silencing trials were unsuccessful, but we've learned a lot from them. They've demonstrated that 1, there's incredible commitment and resolve amongst HD families in seeking for an effective therapy. 2, it's also shown it's possible to carry out rapid yet complex and long duration trials for HD, and that's exactly what we need to find a good treatment. Finally, these trials also generated data of unprecedented depth, which is being actively analyzed right now. So there's much that we'll learn from this, and much to thank the participants for those 2 trials. So on top of that, there's 3 other RNA-based gene therapy drugs being trialed with different mechanism to Roche and Wave. So those drugs may work differently and work better. And there are also 2 other non-gene-based therapies being trialed. In addition to that, as Leora and Rachel will tell you, there are numerous other preclinical compounds that are coming into trial. And as Travis will tell you, there are also trials of non-drug therapies that could potentially improve quality of life. So looking at all this and having worked in Huntington disease with families with Huntington disease over the past 2 decades, I have to say that there's so much hope. Unlike other neurological diseases, we know the precise cause of Huntington disease. And for that reason, we can design rational therapies, and there remains so much hope, despite the fact that the first 2 gene silencing trials didn't work. Thank you for listening, and feel free to put in any other questions, and we'll certainly love to talk about them later. Bye.
Thank you so much, Clement. Could I ask you just to pop back for a second and welcome to those people who've joined us while Professor Clement Loy was speaking, a cognitive neurologist working extensively with people with Huntington's disease at Westmead in Western Sydney. I haven't received questions yet, and I just encourage people, any question is welcome, but I thought I might just ask you a couple of things close to your presentation, if that's okay.
Absolutely.
That you said hope there, because I have to say I'm acutely aware that we've had over 400 registrations, so there'll be people who'll be directly receiving videos of all the presentations, and well over half of those people are family members. And so can you tell us why everything you've just said adds up to hope? What, you know, what's on the, if I came back in 10 years, what do you hope will have been achieved?
There's much hope because the science has moved on. It's also partly because how we organize ourselves has changed. You know, when I started working with families with Huntington disease, there might be 1 or 2 drug trials internationally over 2 or 3 years. In the past 5 years, we have 7 or 8. And also with the internet and, you know, globalization, we could be working on a trial here in Australia, which is at night in Germany, and people in Germany will be working on the same trial during the day for them and at night for us. So things are doubled in speed. I very much hope that there'll be something that would help slow down the disease within the next 10 years.
Okay, and as someone has asked, what are the non-drug therapies that you referred to there briefly?
Travis is going to tell you more about that. But I mean, I trained as a neurologist, so I didn't know a lot about rehabilitation until I worked with our physios. And I've been stunned by how people can be improved after intensive physiotherapy, for example. So there are a number of these things that I'm sure Travis will be able to tell you about.
Well, look, I think Clement is giving me the hint that it would be good to hear our further presentation. So I want Gabrielle to know we note your question and we'll bring it in the panel session. But this is a deaf sign clapping. So even if Clement can't see you, I can. If you could clap wherever you are, because all movement is good for some health prevention. So thank you, Clement, and we'll be back.
Thank you, Julie. Talk to you soon.
People coming in with